Today we're going to be talking about a qualifying round math at the beach problem. This is problem number 9 on the test, and we're given a sequence of functions, f1 of x, f2 of x, f3 of x, etc., etc., etc. So these are all different functions, but they all share a similar pattern as to how they're defined, and they're defined this way. F of n plus 1 of x equals 1 over 1 minus fn of x, with the initial condition that f1 of x equals x, and we're told to find f 2020 of 2020. So we're trying to find this. This is how we define our functions, and basically once we get the function, we plug in 2020 to right here, so f of 2020 equals x, then we can plug in 2020 to x and get our final answer. So in this problem, we have to find both the function and x after we find the function. So how I suggest doing this is finding a pattern. So we can immediately see that f1 of x equals x. That's our given. That's how we're defining the functions in this recurrence equation. Now, if we follow this pattern just to start getting a general idea of what this problem is asking, then f of n, which in this case would be 1, plus 1, because we're trying to find f of 2 of x, equals 1 over 1 minus f1 of x, or you can just write an x, because we're plugging this into right here and f1 of x to right here, but we're adding a 1 to make sure that we're finding the next function in our sequence, or f2 of x. So this is our f2 of x right here. So we can keep rolling with this pattern. However, it would be easier just to plug in the 2020, because the 2020 always stays the same, and we're just going to find a function that is relative to this 2020, and we're going to find a pattern that way rather than finding this function first. So if we go ahead and plug in a 2020 to these two functions, then we get f1 of 2020 equals 2020. f2 of 2020 is equal to 1 minus 1 minus 2020. Into 2020. My bad, I was thinking ahead of myself right there. Equals negative 1 over 2019. So as you can see, if we keep going with this, so f of 3 of 2020, in this way we're slowly working towards this 2020 down here by plugging in the 2020 first. So this would be 1 over 1 minus whatever this x value is of this function. So in this case, it would be negative 1 over 2019. But notice something interesting now. Now we have 1 over 1 plus 1 over 2019. So in effect, this is 2020 over 2019 on the bottom, right? Because this is 2019 over 2019. If we're adding a 1, then it's just 2020 over 2019. So in effect, this is 2019 over 2020. So let's just keep going with this pattern, see where it takes us, because we're eventually going to find this 2020 value. So we get f4 of 2020. We're plugging this value back into whatever this x is right here. So we're going to get 1 minus 2019 over 2020. But now you notice something interesting. 1 minus 2019 over 2020 is 1 over 2020. So, and 1 over 2020 is the same thing as 2020. So somehow, through some form of using this equation, we're looping back to 2020, right? So if we continue this pattern, just to be sure that this pattern's correct, we can see that if we just plug in a 2020 back into this equation, we get another 1 minus 2020, which is essentially equal to 1 over 2019. So as you can see, every 3 numbers, there's a repetition in which the same number repeats. So this function can just be defined as a series of 2020, negative 1 over 2019, 2019 over 2020, and then looping back to 2020 with f of 1 of 2020, this is a 0, this is a 1, being equal to 2020. So every 3 we have a cycle. We know that this value 2020 has to be some value that we need to divide by 3 in order to find what the true answer is. So if we divide 3 into 2020, because the cycle repeats every 3 times, just do some division here, 22, 7, 3, and then we get 0.33. So through this, we know that this value is the first one in the equation. After all, 1 divided by 3 equals 0.33. So 4 divided by 3 equals 0.3, ends in 0.33, and 7 over 3 also ends in 0.33. So we know that this function has to follow in the family that ends in a 0.33. But if we use this 1 and we use this 4 and we use this 7 and plug it into 1, f of 1 of 2020, that equals 2020. f4 of 2020 also equals 2020. And we know that this function has to follow in that family because when I did the long division, it ended in a 0.33. So it is following this family of functions of f7 of 2020 is equal to also 2020. So thus, if we continue this pattern by adding 3 each time, we know that f of 2020 must equal 2020. And that's the answer to this solution because we found the pattern of plugging in first this value and then finding a function, a pattern that's relative to this value through this process.